Okay. All right. So first and foremost, let's talk about what we're doing today. We're going to be talking about radicals, square roots, that type of thing. It's the intro day to it. I'm not going to go too far in depth. I want to get you used to your calculator, because a lot of you have different style calculators than me. Or if you're using mine, you know how to use it proficiently. So if you ever on a test, you know how to type it in. Or if you have your own personal one, I want to make sure that you at least know how to use it to the best of its ability. So here's the idea. What we're looking at today, this is section 3, P.3. This is radicals and roots. Okay, now, here's the idea today. Number one thing I want to make sure of, do we even understand the vocab that are involved in radicals? Okay, because there is some vocab that I will use. Second thing, do we know how to at least simplify a radical? Maybe evaluate it or simplify it. That's the next big thing. Can we at least get to the basics? Now, I know there's a bunch of stuff we can do with simplifying. Now, there's fractions, there's other things that, if you're adding or subtracting or you're multiplying, there's weird things we can do. I'm going to teach you the basics today. Real simple stuff. Then tomorrow we'll kind of go more in depth. We'll get to the more challenging types of problems. But the goal today, remember, is to stay at the kind of the evens keel stuff where you might have remembered it or you at least seen it once and you feel a little bit better about it. But we're going to jump in the deep end tomorrow for sure. This homework, I say, is really straightforward. Basically, the instructions you have, the entire homework assignment, you're going to eventually get either tomorrow or Thursday. It'll be one of the 2 days. The assignment is, seriously, all it says is write the following expression in simplest radical form. So, let's talk about that idea. Simplest radical form. What you're basically doing is you're simplifying an expression that contains a radical. A radical is that actual bar, and you're going down to where you cannot break it down any further. You're going to break down.
Back it up.
Into. Stop. Break down into smallest terms. Basically, that's the easiest way I can explain it to you without using the same wordage. Okay, break it down. So there's no perfect squares, there's no cube roots, there's no quartic roots, if you go to those other types of roots.
Did you just make up the word wordage?
What?
Isn't verbiage, not wordage?
No.
You said, so I don't use the same wordage?
Yes, I just made that up.
Okay.
I make the word all the time. Alright, you're just back there, you missed like 5 o'clock.
Call the dictionary, boys, we got a new one.
Alright, okay, alright. So let's talk about the actual vocab words that are involved here. This is probably the easiest way I can explain it to somebody.
Door's open, somebody shut it. I'm mad.
You're probably okay. So.
Dude, that just bothers me.
Yeah, we're supposed to submit it within the first 5 minutes. I always forget. Because if everyone's here, I just All right. So at this point, what you're looking at here, this is just a rough example of kind of what we're looking at. I'm going to talk about just the words, and then we'll talk about how to simplify. Okay. The item inside the radical sign. This is called the radicand. Radicand. It's the item you are going to simplify. Okay. The next part. Okay, obviously you guys know this, the radical sign itself. Now, don't call it a square root sign or it's called a radical sign. The type of radical, square or cube, that's because of the index number. And the index number is the number on the outside. That is this number. This is an index number. That is actually one of the most important numbers of a radical. That's part that I think most people don't get in Algebra 2 is that they're not told that the index number is the thing you need to look at first when you first start the problem, and how to use it. And then the 5 out front is a leading coefficient. You can still have numbers and digits out front. These are still leading coefficients. And that's the part that maybe in previous years you probably don't get a lot, is that they don't show when there's numbers out front versus an index number. Some people get them confused. You can still have digits out front of the radical because these are just being multiplied on the radical itself. Right, just 5 times whatever that radical is. So it's kind of like the unknown. Okay, questions on the actual vocabulary terms I'm going to use. Now obviously I haven't talked about how to break this stuff down or simplify it, but the reason I bring this up is it's kind of nice to know the words I'm going to use, just because when I start asking you questions, very specific things about your problem, if you have questions, you know what I'm talking about. Like, what's your index number? You know what to look at first. What's your radicand? You can tell me that. And so that we're on the same page, you're not lost completely. All right. Questions before I actually start this process of how to simplify. Okay. So, let's discuss the ideas of what we're doing. Obviously, we're going to be trying to simplify radicals, but the idea is that what we're trying to do is break it down where you can't go any further. Lowest terms, that's kind of the easiest idea. So let me explain. I'm going to just start with easy numbers, like square root of 4 and kind of clean numbers, and then we'll kind of work our way to the more challenging ones. What you're looking at here, obviously the radicand is a 4. The index number inside here. Does anyone happen to know what the index number is if it's not printed?
2.
It's a 2. Okay. It's a 2 if it's not printed. If it's any other number, they have to automatically have that print provided for you. So it's assumed it's a 2. It's the only time in math we assume 2. Everything else in math is always assumed it's 1s, right? If you had like a variable, we assume the power is a 1, the leading number out front's a 1. But on radicals, it's a 2. If they have any other number, they'll print it in there, like a 3 or a 4 or a 5. If you look at my tests, Microsoft Word prints the index number up here. They print it a little bit higher. It's small, but it's higher. Just so you know, it's out front. It's not the large number out front. No, if there's a 7 out here, it's not that number. It's just a little tiny number in the actual like tail. Okay, so in this case, this is a square root. Okay, I'm going to put a 2 there, even though you don't need it. What you're doing and how I actually simplify this and the real process is what you're supposed to be doing is look at this number first. The index number tells you you're looking for 2 numbers that are multiplied together. Now, obviously, it's got to be the same number multiplied on itself. That's what that little index number 2 means. There's 2 numbers multiplied together. And you're looking at what are the numbers that multiply together that would give you the number on the inside. That's the whole concept of what you're doing. So if this is a 3 sitting here, then you're looking for 3 numbers that are multiplied together. And it's got to be the same number each time. That's the concept. All right, questions with the basic terminology and like what we're looking at. Now obviously, what's the square root? 4? 2. Everyone knows it. Now, this number. This is called the principal square root. Principal square root is the positive radical that you have. It's a positive number. There is a second answer, which is -2, but the principal square root is the positive answer. Questions at all about the term and why they call it what they do? That's usually the one I'm looking for. Now I know there's 2. I'll explain why there's 2 here in a second. Okay.
Oh crap, I gotta go.
Okay. Questions about principal or negative and positives? All right. Here's why. Here's where the problem actually comes from. This is the original problem that gave us this for its answer. What you're doing is you're trying to get rid of a power of 2 off of an x, so what you do is you take it to the other side and you do the opposite operation. The opposite of a square is a square root. That's the concept. Okay. So if we have a 4 here, this index number is a 2, that's why it sits there. Because the original square was a 2, this is a square root. Does everyone see why the 2 is sitting? Now, there is 2 answers. You're supposed to have a positive and negative. The reason why there's a positive and negative, why there's 2 actual answers, is because when you square a number, like the original part, is when you square something, it's times itself, the negatives would cancel each other out. That's why you could use negative or a positive number. There's 2 numbers. So anytime there's an even power, it's typically, there could be 2 potential answers. If there's an odd number, it's 1 potential answer. Because if it's, let's say this is a 3. Well, you have 3 numbers multiplied, there's only 1 answer. It's either going to be even or odd. Sorry, positive or negative, I should say. Because when you have 3 numbers, if all these are negatives, your answer is negative. So like there's 1 answer on an odd power. So just keep that in mind. Okay, what I'm going to give to you right now is the perfect square chart and the cube chart. And let's go through those first. Close it a little bit, let's get the noise. Okay, so here's the chart I'd like you to write down.
It's supposed to rain like right now.
I'll do it.
It's literally only supposed to rain right now, but not any other time during the day.
Okay, all right, perfect squares. Here's a list I need you to have. These need to be in your notes somewhere. This will make it easier for you, but I'll show you a different way to do it if you don't like this list. So, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay, and obviously there's more. This is just the list that I've had memorized since college. These are the list of numbers that have perfect squares. In order, right? So, how I made this list, it's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. These are the numbers that if you had them inside a radical, you can break them down. They can be simplified to a nice clean whole number, or a natural number. Like we just did the number 4, right? The square root of 4 is 2. It's literally the second number on my list. If I had the square root of 64, well, you look down the list, it's the 8th number down the road. So, so the square root of 64 would be 8. Questions at all about this list of numbers? Anything that falls in between, let's say like the square root of 12. Now the square root of 12 is between 9 and 16. It's no longer a nice clean whole number. It will be a decimal. The decimal is literally between, what's the square root of 9? 3, the square root of 16. The decimal is between 3 and 4. That's how I estimate it in my head. Some people have never taught that. Like, how do you guess or how do you estimate decimals? You figure out the square roots that are around it. And so that gives me a ballpark. The square root of 12 is closer to 3 than it is 4. Just because where 12 sits. 12 sits closer to 9 than it does 16. 3.4 something. Like you can get really exact with the type of square root. Just depending on where it sits between the 2 numbers. Does that make sense now? So I would say, like, without even knowing this number, 3.4 ballpark. And that's without me even knowing it. I don't know the square root of 12. That's just guessing at it. Okay, now let's learn how to type this in. Okay, so to hit the square root key on my calculator. Now this is my calculator only. You have to hit the little second key first. The little shift key. You have to find the little x squared key. That for my calculator, it's like right here. It's right next to the number 7. Then you type in the 12, and then hit enter, and it should tell you. Say it again.
3.464.
3.464. And keeps going. Okay. Now, if yours is giving you an error, obviously we have to type yours in differently. Maybe you use the wrong radical. Okay. We're looking for the square root key, not like an x to the square root key. Because I know some people have this for a button. That's not the button I want. I want the one that's just a radical. Okay. Is anyone struggling with how to type it in? Now, some calculators in here will give you a nice clean whole number, like they'll break down the radicals and not give you a decimal, which is simplest radical form. It does it for you automatically, which is really nice. I think for you, just hit the little SD button, and it will convert it back to like a nice clean decimal, which is really nice. That's a really nice calculator. So my $100 one can't do that. So, like Cole, I think you have the same situation. Yours can do it kind of both ways, which is really nice. Frank, maybe yours can do it too. They can either do decimals or nice clean radicals, like they can do both. So, which is really nice. Those are really nice. Is anyone struggling with how to type it in?
Everything $15
Yeah, nice. Those are nice calculators. I tell you, they can do a lot more than they used to.
Hammer's gonna see a freak out right here.
Okay, all right. Now, let's talk about what I want. Because obviously it's nice to know the decimal. It is. If I have the decimal, I can estimate what my answer is. But the problem is, I don't want a decimal. I want to know the cleanest form of it, the simplest form of my answers, right? So that's where you have to learn how to break it down. That's where this chart can be your best friend, or I can show you a completely different way of doing it. I'm going to show you both ways. Because some people like the method I'm about to show you, and some people like to use this chart strictly, because they have something to go off. So I'm going to show you both ways to do this round. All right, let's start with so if you have a room, write down the square root of 12 one more time, and give yourself some space. We're going to do this two different ways. This is how we simplify a radical, and this is two different methods. This is my way of doing it. That way you don't have to think about it, it just works every single time. Square root of 12. Some people just want a mindless way of doing it. What you do is you break down 12 into its prime numbers as fast as you can. Prime numbers are 2, 3s, 5s, 7s, and you go as far as you can. So without thinking about this, let's break down 12. What are two numbers that multiply to give you 12?
4 and 3.
Okay, 4 and 3. If you were the person that said 2 and 6, write 2 and 6. I don't really care. Then what you do is you go one step further, and if you can break down any of the numbers on the inside, you go further. Well, I can break down the number 4. So that's 2 times 2 times 3. Does that make sense? That's going as far. No matter which order you did, if you were the 2 and 6 person or 4 and 3, everyone should have got down to this basic form at some point. And I didn't have to think about it. You just break it down as fast as you can. I don't want any decimals in here. I just want nice, clean numbers. And you broke down everything as far as you can without using the number 1. Does that make sense so far? Now, what we look at, and this is the first method of doing this. What is my index number outside? 2. So what this index number tells me, I'm looking for pairs of numbers. Is there any pairs of numbers, two numbers that match on the inside of the radical? Yes, there's a pair of 2s. If you had any other pairs, circle those. You could have pairs of 2s, pairs of 3s, pairs of 7s, maybe you have multiple pairs of 2s. I don't care, I'll give you another example here in a minute where you have multiple pairs of things. But whatever you do, here's how you do it. You kick one of them out and you cross one out. That's how the pairs always work. One leaves, the others go away. So the 2 will go to the outside, because I kicked it outside the radical house. One of them disappeared, and the 3, do you agree the 3 didn't have any other pairs? So that will stay in the radical house. That is simplest form. That's how it always works no matter what the number is. This works for cube roots, quadratic roots. I can show you how to do it for any type of radical, but that is my fastest way of doing it without thinking about it. So to give you an idea, I'll give you another example. I'm going to pick a number that has more than one group of numbers here. So let's go with, okay, I'm going to give you a big number here, just so you get the idea. 3,920. Okay, so I went a little overboard, but I want to show you the concept of how this system works even on big numbers. Obviously, with 3,920, do you agree that 2 goes into it? So I'll break down by 2. So if I break down by 2, 3,920 divided by 2, that's 19620. Or sorry, 1960 and then the 2. Right? 1,960. Obviously, a 2 goes into that even further. So I'm going to break down the 1,960, divide that by 2. I get 980. Are you still sticking with me how I'm doing this so far? So I broke that one down by 2. 980, I can go down by 2 again. So I'm going to go by 2 again, so divide that by 2. That's 490. So I'm just breaking these down by 2s until I run out of 2s, and then I'll try 3, then I'll try 5, then I'll try 7. I'll just keep going. 490 divided by 2.
I go 7.
245. So I think I'm out of 2s now. Run out of pairs of 2s. 245. That is a. So 3 does not go into that, because if you add a 2, a 4, and a 5, 3 doesn't go into 2 plus 4 plus 5. That's 11. So 2 and 3 wouldn't go into it. 5 does. 245 divided by 5 is 49. Hopefully everyone's still sticking with me and I haven't lost anybody. And 49. What, 7 and 7? Okay, so bringing this down as far as we can, here's what I have. 2, 2, 2, 2, 5, 7, 7. That's the complete breakdown of the 3,920. I didn't have to think too hard. The calculator pretty much did most of it. I just divided by 2s, divided by 3s, divided by 5s until I got down to as far as I could without having to go any further. The hardest part is if you get to a prime number that you're not sure, like the number 37, you're like, is that even prime? You'd have to kind of double check. Okay, now, once I get here, what's my index number on the outside? A 2. I always look at my index number, because that's telling you what I'm looking for. I'm looking for pairs of numbers. 2 numbers that match. That's what my index numbers tell me. I have a couple of pairs. I have some pairs. I have pairs of 2s, I have another pair of 2, and I have a pair of 7s. What do we do with pairs? Kick them out. You always kick one of the pair out, and you cross one of them out. So when I do this, when I start kicking these pairs out, a 2 goes to the outside, that one's gone. A 2 goes to the outside, that one's gone. A 7 goes to the outside, and that one's gone. You always kick one of the pairs out. So outside my radical, I have a 2, 2, and a 7. What's left inside? A 5. The 5 had no pair, it's stuck. And what you do is you just multiply the 2 times 7, which is 28. So this is your simplest form. It's 28 root 5. That's my easiest way of explaining it to you, the best way I can do it. Is it the only way? No, by no means. Like some people use this chart to figure it out. What I mean by use this chart, they'll look at their problem, the 3920, and they'll try to pick out numbers up here that clearly worked. Like they would try 4, they would try 16, they would try 49, they would try different numbers and kick those out. I'll show you that concept here in a second. But that's the answer. That is simplest form where I can't break down the radicals any further. Was that a decimal? Yeah, it was. How do I know it's a decimal? There's still a radical 5 left over. So it wasn't a nice natural number. It actually ended up being irrational. Irrational numbers are numbers that never end or repeat, like pi superrational. Okay, but let me show you the other way. Some people don't like that way. That way maybe takes too long. Some people want the short way to do it. Well, here's another way you can do that same exact problem. This isn't the best way to do it. It's just a different way to do it. So what you do, 3920, right, same number, is you start on this list and you see what numbers go into it. And you just go with, like, for instance, do you agree that this ended in a 20? I know a 4 automatically goes in. Because I knew it ended in a 20, so the last 2 digits tell me like a 4 goes into it. So I could break that down by 4. What is the square root of 4? Well, if I divide this by 4, taking a 4 out, whatever's left, if I took out a 4, what is that? 980. 980 is left inside the radical. If the 4, I just take the square root of 4. What's the square root of 4? That goes on the outside. Like you could just pick numbers that automatically work. So when you know a number from this list goes in there, just take the square root of that number, pop it to the outside, and whatever's left, you leave it there. 80. Do we agree that a 4 goes into it again? Because it's an 80, right? So 980 divided by 4. That means if I take the square root of 4, there'll be another 2 on the outside. And 980 divided by 4. Yeah, but 10's not in the list. What was that? 245? What we said? And then the last step is to, on 245, is to check any of these other numbers. Like try 4 again. 4 is not going to work. 4 doesn't go to 45. Try 9. Try 16. Try 25. Try 36. Try 49. 49 worked. I can divide that by 49. And it would be a 5. And the square root of 49 is 7. So like that's another way you could do it. You're just picking numbers up here that you know work and taking the square root of those. Whatever's left stays in the radical. Now, it kind of looks like what I did, but my way didn't take any mental thought until the very last step. This actually, you have to like be thinking about it constantly as you work through it. Okay, what goes into it? Does a 4 go into it? Does a 16 go into it? Does a 25? And you have to constantly be checking what's left and keeping track of what you're taking out. I'm betting on most people will probably stick with that method, unless it's a crazy big number, then you try like these numbers. You'll try to break down as fast as you can. Now, here's the weird thing. This also works on letters, variables. That's why this method that I've shown you here is a preferred method. Even with letters, you can break down letters into pairs and whatnot, if you just understand what a power means. So like for instance, if I gave you, this is x to the 3rd, right? Breaking these down into pairs and whatnot, with like x's, you can still circle pairs of x's and still kick them out the same way. It still works. That's the beauty of doing it. All right, questions at all about the concept of radicals and variables and numbers? Okay, now tomorrow, obviously tomorrow, we're going to look at how to add radicals together, how to multiply, how to divide. Those are like my 3 big topics I want to talk about tomorrow. And then we're going to do kind of more challenging ones like cube roots, fourth roots, and all that good stuff. Questions at all about this concept? That was the intro day. Hopefully this makes a little more sense to you. Homework due today. I'll go through answers here in a minute. If you have a question on a certain problem, you can turn it in baskets. But homework is due before you leave, so make sure you're getting that done. I'm going to turn off the camera and you can ask questions.